Aluminum is one of the most versatile metals in the world. It bends like paper and resists like steel. It's used for preserving and cooking food. But how is aluminum foil made? In this video, we will discover how millions of tons of ore are processed to produce rolls of aluminum foil. Aluminum foil was invented by the American company Reynolds Wrap in 1947, and has become a widely used material in the kitchen due to its durability, water resistance, and thermal insulation capabilities. The shiny side of aluminum foil helps reflect far infrared rays, keeping the food warm. The process for obtaining aluminum used to be so complex and expensive that aluminum was more valuable than gold until the beginning of the 20th century. The first step in making aluminum foil is obtaining the raw material, in this case, pure aluminum. Pure aluminum is extracted from bauxite, a mineral found in large quantities in the Earth's crust. Bauxite is mainly extracted in tropical countries and is shipped to aluminum refineries. From this red earth called bauxite, a white powder known as aluminum oxide is extracted. It's later used to manufacture aluminum foil or beverage cans. Aluminum is the third most common element in the Earth's crust. Bauxite is the only mineral from which aluminum can be economically extracted. This is the largest bauxite mine in the world. The Alcoa mine is located in the middle of the Australian mountain range. Around 23 million tons of bauxite is extracted here per year. However, the majority of it cannot be extracted without breaking through an underground rock barrier that extends more than 5 meters deep. The excavator handles a daily movement of 7,000 tons of bauxite. The jungle bauxite has over 50% aluminum oxide. The water demand of a bauxite mine is enormous. Water is directed to huge washers where clay and other low aluminum components of bauxite are removed. Now the trick is to separate aluminum and oxygen from the rest of the bauxite components. This involves grinding the mineral into powder. The finely ground bauxite is transported in freighters to aluminum refineries for further processing. The aluminum atom in bauxite is bound to oxygen molecules. These bonds must be broken through electrolysis to produce pure aluminum. Next, through a chemical transformation called the Bayer process, alumina is extracted, which will later be heated to remove all moisture. The crushed mineral is transported to facilities like Alcoa's refinery. There, the transformation to extract aluminum oxide from bauxite takes place where caustic soda is required in large quantity. It's a relatively ancient process, over 100 years old. Bauxite is introduced into a pressurized solution along with caustic soda. The bauxite powder is mixed with the caustic fluid, which separates aluminum oxide from mud, resulting in a concentrated solution of aluminum oxide. And here's the amazing part. The solution is dried and transformed into a white powder called alumina. This white powder is the starting material for countless applications, but it's primarily used for the production of metallic aluminum. The loader fills ships with up to 70,000 tons of alumina. The alumina it carries will be transformed by a smelter into 35,000 tons of pure aluminum. But to obtain pure aluminum, it's necessary to break the oxygen atoms that are tightly bound to it. The way to do this is by using large amounts of electricity. The white powder travels on a conveyor belt directly to the smelter. Here, the white powder is finally converted into pure aluminum. This factory has 432 crucibles, inside of which a powerful electric current is applied to produce electrolysis. The powder is introduced into the furnaces. There, it dissolves in a bath at 950 degrees Celsius. The melting temperature of aluminum is 660 degrees Celsius. A strong current circulates inside the furnaces. This causes aluminum particles to dissolve from the white powder. The force of the electrons breaks the bonds that hold aluminum to oxygen. The oxygen rises to the top of the crucible, while the denser ground aluminum sinks. The production of aluminum consumes 10 times more energy than that of steel, and this energy becomes stored in the metal. Liquid aluminum is highly reactive, and contact with water is very dangerous, as it releases as much energy as a dynamite explosion. With each transformation stage, the value of the raw material multiplies by 5. 1/3 of the cost of 1 kilogram of aluminum corresponds to electricity. Despite the energy-intensive nature of aluminum production, Once aluminum oxide is released from the oxygen atoms, metallic aluminum becomes very stable. This means it can be melted and reused over and over again without any limitations. To meet the demand, this operation runs 24 hours a day, 7 days a week, and produces over 154,000 tons of aluminum per year. Now, the aluminum needs to be taken out of one of the crucibles. Each one produces about 1.5 tons of aluminum per day. The crucibles filled with molten aluminum are transported to the molding area. The molten aluminum is poured into molds to form ingots, which are solid rectangular blocks of aluminum. The molds are cooled with water to accelerate the solidification of the molten aluminum. The ingots are demolded and are ready for milling. Each ingot is massive, measuring 4.5 meters in length and 1.5 meters in width. It weighs an astounding 8 tons, so it needs to be handled with cranes and placed on special platforms. This impurity removal machine shaves off a 3 mm thickness from the ingots. Impurities are removed to achieve a perfectly smooth finish. All traces of liquid used to cool the blades must be eliminated. Next, these aluminum ingots are sent to factories that produce aluminum foil. The manufacturing of aluminum foil requires the repeated thinning of a large aluminum block. The second step in paper production is rolling. In this process, the aluminum ingots are heated to an appropriate temperature and pass through a series of rollers that crush and stretch them, reducing their thickness and increasing their length. The heat is so high that the ingot risks sticking to the mill roller. To prevent this, everything is cooled with a liquid that is 95% water and 5% oil. Starting at a thickness of 45 centimeters, the ingot becomes thinner with each pass. The ingot passes through the machine between 12 and 16 times. This rolling process takes place in multiple stages, each using rollers of different sizes and shapes to produce progressively thinner and more uniform aluminum sheets. The ingot has been transformed into a sheet half a centimeter thick. It's thin enough to pass to the winding machine, where it's rolled up before being sent to the cold rolling mill. There, its thickness will be further reduced during paper production. The aluminum layers come into contact with rollers of different textures, creating different finishes on the two sides of the foil. The aluminum sheet is a few millimeters thick and at risk of breaking due to the tension required for cold rolling. To prevent the sheet from sticking to the rollers, a coolant liquid is used. This cold rolling process is conducted to prevent the sheet from getting too hot and damaged. The final step is strengthening. In this process, the aluminum sheets are heated to a high temperature for a specified period to reduce their hardness and improve their flexibility, making them easier to bend and mold. The aluminum sheets are cut into standard-sized pieces and rolled into rolls of various sizes. Once the aluminum foil has been processed, it's ready to be shipped and used in the kitchen for wrapping food. If you want to know how sugar is made, watch the video on your screen. And please like the video if you enjoyed it and share it with someone who might be interested. Also, subscribe to this channel by activating the notifications to continue learning. Thanks for watching.